So we are going to be discussing triangle congruence theorems. The assignment is also called triangle congruence theorems. And you may try the assignment without watching this video if you would like, because the assignment that I have assigned you is actually one that I give to subs a lot. Whenever I have a sub, these are the kind of assignments that I give because you can actually learn them by just reading. There's a lot of reading in the first couple pages. But if you're not interested in looking at the reading and you want to just watch the video, please feel free. But this one, I think you have the option. I think you can figure this assignment out without watching the video. So hopefully that helps. Enjoy. Thank you. We are looking at triangle congruence theorems today. So triangle congruence theorems look at are two triangles congruent? What does congruent mean? Well, congruence means the same size and the same shape. And it has a symbol. So congruent is an equal sign with a little squiggle on top. Now at first glance, these two triangles look like they might be congruent. They might be the same size and the same shape. We're not sure. We could tell if we knew some information. So if I knew that those two sides were the same length, that's a start. If I knew these two sides were the same length, that would help. If I knew these two sides were the same length, that would help. So the single dash means that they're the same length. Double dash means that they're the same length. Triple dash means that they're the same length. Also, if I knew this angle was the same measure, so if I were to measure how many degrees, the degrees were the same, the two angle measures were the same, then I would know a little bit more. I'd have more confidence that these two triangles are congruent. They're the same size and shape. If I have that, even more. And if I had that, I'm guaranteed same size and same shape. So these two triangles are congruent because they have the same size, each side is the same length, and the same shape. Each angle is the same angle. So they have congruent sides and angle measures. So they must be congruent. So this is enough information for me to say, yep, they are congruent. So how much information do you have to know that two triangles are congruent? So that's kind of the question that we're kind of going over right now, is how many different sides and angles do we have to have, and is there different combinations that matter? So let's say that we didn't know that the third angle was the same measure. We had two of the three, and we had the three sides. Would that be enough information to say, yes, these are still congruent? And the answer is yes, most definitely. And that's because if this angle is, say, 40 degrees, and this angle here is 70 degrees, 40 and 70. The triangle sum theorem states that the interior angles of a triangle always add up to 180. They always add up to 180. So 40 degrees plus 70 degrees plus the question, whatever this is, must equal 180. So if we subtract 70 and 40 from 180, not divide, subtract 40. We get 70. So this question mark is 70. Well, this is 40 and 70. If we do the same for that one, we're going to get 70. So even though we don't know what those angles are until we do the calculation, we can find out. We don't even have to find out. Since two of the three angles are the same, the third angle must be the same. So that's pretty helpful. So then I guess the question is, could we remove more information? How much information is enough information? Just enough. So we generally have the rule of 3. You need 3 pieces of information. So in a triangle and another triangle, trying to make them the same size roughly. I made this one quite a bit smaller. Let's see if we can make it a little closer to the right size. Okay. Still made it a little small, but that's okay. All right, so if they are the same size, the rule of 3 usually works. So a side, an angle, and a side. That is enough information, and that is shorthand the rule as SAS, side, angle, side. So side, angle, side. So side, angle, side states that if a side is congruent to another triangle side, and another side, a second side, is congruent, and the included angle, the angle between those two sides, is known, that is side, angle, side, side, angle, side, then the two triangles must be congruent. And we will see later that that is definitely true, but right now I want us to see the theorems. So these are the triangle congruence theorems. So side, angle, side is a congruence theorem. So SAS is 1. Side, angle, side, side, angle, angle. Some textbooks write it side, angle, angle, and other textbooks write it angle, angle, side. I like angle, angle, side, personally, instead of side, angle, angle. So angle, angle, side. What other combinations are there? There is angle, side, angle. There is side, side, angle. There is angle, angle, angle. There is side, side, side. Let's see. Angle, side, angle. Angle, angle, side, angle, side, angle, 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 side, side, side. And then there's one where you just have HL. So here's, I think we've got all the combinations. I do believe we've got them all. If not, I'm sorry, we'll have to come back and look at those. But I think we've got them all. They don't all work. Side, angle, side is a good one. Angle, angle, side is a good one. Angle, side, angle is a good one. Side, side, side is a good one. And hypotenuse leg is a good one. So those are the 5. And there are only 5. There's 5. Angle, angle, angle does not work, and I can prove it really easily. So it's easy to prove them wrong. It might be a little more challenging to prove these right. But it's much easier to prove these two wrong. They don't work. So angle, angle, angle does not work. So here's a triangle where we've got angle 1, angle 2, and angle 3. And here's another triangle that has the same angles. Angle 1, angle 2, angle 3. Are they the same size? No. Are they the same shape? Yes. They are similar shapes. This is like a Hot Wheels car versus a real car. You can get in a real car. You can't get in a Hot Wheels car. The Hot Wheels car is too small, right? So this is a same shape, different size, not congruent. Angle, angle, angle might be congruent. They might have the same size, but we don't know it. This is not enough information. We would need to have another side. If we had angle, 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 and a side, we're good to go. But that's angle, angle, side. So this is the minimum amount of information that you need. The next one is angle, side, side. I wrote it side, side, angle, but angle, side, side is not going to work. So let's go ahead and look at why angle, side, side does not work. Again, I can prove this, I think, pretty clearly to you. If we knew two sides in an angle, side, there we go, angle, make this a tiny angle, tinier, there we go. Okay, so I've got it now. So we've got angle, side, side, but we've got another triangle that meets this requirement, and that's over here. This side length and this side length are the same, so we've got a second triangle that meets it. So this triangle and the big purple triangle are the two triangles. So I just kind of squish that down over here. So you can see you've got two triangles that are not congruent, yet both share an angle, a side, and a side length. So this is why angle, side, side does not work. I like to call it the hinge, kind of a hinge idea. So it's a swinging door. This door swings, and it's the same length all the way around. You could even see kind of the circle that's being formed, where this is the center of the circle, and you're just rotating that door. That door meets over here, and it also meets over here on this line. So you get an angle, side, side, and another triangle that's angle, side, side. Two triangles, different size, different shape. So it fails the angle, side, side. There's a special time when angle, side, side works, and that's when, so angle, side, side angle does work, but only in special circumstances. So here's the one that it actually works in. So you have your two triangles. They are congruent with angle, side, side, angle, side, side, only if we know the angle is 90. If the angle is known, and it is 90, angle, side, side is enough. And we could use the Pythagorean theorem, a squared plus b squared equals c squared. A squared plus b squared equals c squared. They have the same b then, because A and C, they must have the same b. And so we'd have side, side, side then. So hypotenuse leg is what this is called. Instead of angle, side, side, it's called hypotenuse leg. Hypotenuse leg. And it's worth noting. So the hypotenuse is the side opposite the 90. So this is the hypotenuse. The hypotenuse is known. We also know it's the hypotenuse because the 90 degrees is known. And one of the sides is also known. Besides the 90 and the hypotenuse, we also know one of the side lengths. So we call that a leg to a right triangle. The right triangle always has a hypotenuse and two legs. One of the legs is known for each triangle, and they're the same length. The hypotenuses are known for both triangles, and the hypotenuses are the same length. And the 90s are known, they're both 90-degree angles. Then that is a special case where angle, side, side works. And we don't call it angle, side, side, though. We call it HL, hypotenuse leg. So these are the 5. Hypotenuse leg, side, 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 angle, side, angle, angle, side, and angle, side, angle. So hopefully that helps. We are going to prove that triangle ABC is congruent to the triangle EDC. So in this case, we have been given the triangles and the right order in which we need to write it. So that's nice in our proof. So our end answer will be triangle ABC is congruent to triangle EDC. We need to write it in this order. That's the order they gave us. And actually that's the best, because you already know what order it needs to be written in. So we're proving that those triangles are congruent. So our statement and reasoning. All right. The first statement I'm going to make is that AB, segment AB, is congruent to segment ED. And that's because it's given by this dash. So that's given. The next is that angle D, is congruent to angle B. And that is also given. Angle D, angle B. There is no ambiguity here. There's no question what angle D is. This is angle D. There's no other angles attached to this point D. So I can say angle D. I don't have to give 3 letters in this case. If I were talking about angle C, there's a ton of different angles that exist at angle C. There's angle ECD, there's angle ACB, there's angle ECB, there's angle ACD. There's just too many angles. So if I wanted to talk about an angle that was formed at C, I'd have to list the 3 letters. But since I'm talking about an angle that's got only 2 segments coming out of it, and this is the vertex of that angle, there's only one angle. So I can just state the letter. So you might say again, there's not really a clear congruence here, and that's because we need to see that there is a special case going on. This special case is that they have a shared vertex for an angle that's coming out of lines that are straight. So DB is a segment, EA is a segment, and we're not assuming that we can see that. So we're not assuming that. What we're saying is it's forming an X, and so this angle here must be the same as this angle here, because they are vertical angles. Another way of looking at it is this angle here plus this angle here. These 2 angles add up to 180. They form a straight line. And these 2 angles add up to 180. They form a straight line. These 2 make a straight line. These 2 make a straight line. And they have a shared value in between them. So these 2 angles must be the same. We can say it the other way as well, right? So we could say these 2 angles make a 180, and these 2 angles make a 180, and they have a shared angle that we could subtract away from them, so these 2 angles must be the same. You can do this algebraically as well. So you could say angle BCA plus angle ACD. BCA and ACD must equal 180 because they form a straight line. And we can also say that ECD plus angle ACD equals 180 because they form a straight line. If that's true, if they both equal 180, then they must equal each other. So we could say angle BCA plus angle ACD equals angle ECD plus angle ACD. These 2 angles must be equal. They equal 180. Well, ACD we could subtract angle ACD. Subtract angle ACD. From both sides of the equal sign, they cancel out. So angle BCA and angle ECD must be congruent. These two angles must be congruent, and we proved it algebraically over here. But you don't have to do that every time. Instead, what you're going to say is angle ECD is congruent to angle ACB. And that is by what we call the VAT, vertical angle theorem. Lines that cross the angles opposite each other are congruent. These are called vertical angles. And that is always the case. This angle and this angle are congruent. This angle over here and this angle over here are congruent. Because they are vertical angles, they are vertical apart from each other on either side of the two lines that are crossing, forming that X. So that's the VAT. It just proves that this is always true no matter what two lines cross. The angles opposite each other are congruent. So now that we know that, we have angle, angle, side, angle, angle, side. So this is angle, angle, side. And we can prove angle, angle, side. So since we know that we have an angle, angle, side, angle, angle, side, angle, angle, side, that is enough to prove that triangle ABC is congruent to triangle EDC. And there you go. So that is a proof. So our 5 big choices are angle, angle, side. That would be a triangle that was angle, angle, side. Side, angle, side. Side, angle, side. Angle, side, angle. Angle, side, angle. Side, side, side. And the last is HL, hypotenuse leg. And there you go. So those are the 5. So there are only 5. Obviously, if you have more information than that, you have more than enough to prove. So as long as you have one of these 5, additional information is just extra. You don't need more than that. That's all the information you have to make an informed decision on whether or not 2 triangles are congruent. So hopefully that helps. Come with questions to class, and then also you can Canvas message me if you have questions. Thank you so much.